Assalamu alaikum. In this lab session, example 2.3 and its method of modal analysis for determination of Young's modulus from the nature of frequency measurement. Its method will be explained in this lab session. So the statement for the problem is shown here. A simply supported beam of square cross section 5x5 and length 1 meter carrying a mass of this value at the middle is found to have a natural frequency of transverse vibration of 30 radians per second. As we observed that the frequency is shown here, so it says that determine the Young's modulus of elasticity of the beam. Our task is simply to verify this frequency and simulate the model using these values. So remember, there is a mistake in the statement. Here it is written a simply supported beam. It is wrong. Here it must be a fixed ended beam. Means fixed ended beam, a beam which is fixed at both ends, because the reason is that the formula for the stiffness is 192 EI over L cube is for the fixed ended beam. It is not for the simply supported beam. We can search through internet, and I have gone through here. We can show here that I have downloaded this document from the internet, and here you can verify that for simply supported beam, when it is loaded at the center, here we can observe that for the simple beam or simply supported beam concentrated load at the center, here this is the formula, maximum deflection of load at the center. The formula is PL, deflection formula is PL cube by 48 EI. So for the stiffness it will be 48 EI over L cube for the simply supported beam. So this formula, and we can further verify that at the last here is given for the fixed ended beam. Here we can observe that for the fixed ended beam fixed at both ends, the concentrated load at the center. Here the formula for deflection at the center is PL cube by 192 EI. So the formula for the stiffness will be 192 EI over L cube. So in this way, we must remember that there is a mistake in the statement of this example. So it is not simply supported, it is a fixed ended beam which is fixed at both ends. So let us create the beam. So launch a model module and click on geometry cell. And here we will click on XY plane and go to sketching tab and click on positive Z axis to put in planar mode. And after that, we can create a fixed ended beam. For example, we can create a simple line and segment here, and remember to create the fixed ended beam which the load at which is located at its center. So what we will be doing here, the dimension are given that the mass at the center is 2.3 kilogram and length of this beam is 1 meter. and natural frequency or the circular frequency 30 radian per second. So we can convert it into hertz, and in hertz it comes out to be, for example, we will be dividing it by 2 pi, so it will come out to be 4.7746. So in hertz, this linear frequency will come out to be 4.7746 hertz. So we will be verifying it, and we can create this beam as two line segment, each having a 0.5 meter length, so that the load could be applied at the center. So here it must be 0.5, and we can zoom fit here, and if we can use the move option in the dimension, and further we can set, and in a similar manner we can create the other line segment here, other line segment here, or yeah, we can dimension it, or we can apply equal length constraint, so make this line segment to be equal to this line. So this total length of 1 meter beam has been created. So create this line segment to be in line body, click on concept and go line from sketches and click on apply and add materials and generate. And next we will be applying concept into cross section, and we can assign a rectangular cross section. Rectangular cross section, for this the cross section here is square cross section, as we can observe 5x5 millimeter. So in meter it will come out to be 0.005 meter. So we can change the dimension at 0.005 meter and also 0.005 meter. So in this way now we will be applying this cross section to this beam, and then we can check cross section solids here like this, and then we can make these section planes off, and then click and show it in isometric mode. And as we can observe that the section of 5x5 millimeter has been created. So in this way model has been created. So after that we can either close this design modeler module, and remember that now our task will be making this beam as massless, so that we will only be checking the effect of the concentrated load at the center. So we can change its density to be, for example, 1 minus 10 raised power 40. One E minus 40. So in this way, and after that we will be clicking on model cell A4, and also to note that here we will be inputting this value of the modulus of elasticity, which has been calculated using this data. So we can input this value of the modulus of elasticity in engineering data. So click again on engineering data and change here the Young's modulus and Young's modulus value is 207.0132. So 207.0132 E7, sorry, 10 raised power, it is 9. So the value for the Young's modulus is this value. So here we can observe that engineer data has been applied, and after that we will be refreshing the materials like this, and then we will simply be clicking on insert and point mesh at the central location. For example, this is the center of the beam. We can click on z-axis here. So at this center we can apply that this point mass is 2.3 kilogram. So we can input 2.3 kilogram, and after that we will be clicking on applying to fixed support, not the simply supported support. So fix this end as well, and apply another fixed support on the other end here at this point, and both of these ends have been fixed. And one next task is that we will be applying a displacement support at the mass point so that it is confined to move in the vertical orientation. So x must be 0, y must be free, and z must also be 0. In this way, the model has been completed, and after that we will be clicking on insert and deformation and total deformation, and then we can solve it to check if there is any mistake, and we will be revising it. As we can observe that the frequency for the beam is same as which was calculated, because it was uh, 30 radian per second, and when converted it in hertz it came out to be 4.7746. So the same value using same data it has been obtained. So in this way it has been simulated successfully. Thanks all for listening and bearing. Assalamu alaikum.